Okay, so now we'll continue with how to write a time delay by using a C programming. Okay, there are three ways to create a time delay in AVRC programming. The first one here, we're using a simple for loop, means that you do a looping in order to create a delay. The second one here, you can use the predefined sim function. Okay, you use the sim function or seal and that the delay function that already created in the C library. Okay, so you can use that function in order to create your delay. And the third one here is AVR timers. Okay, for the AVR timers, you need to do a calculation. Okay, based on the delay that you're going to use. Okay, so for the AVR timers here, we will learn in the next module, right? This one here is to calculate a delay. Okay, so this is an example how we're going to create a delay. So you're going to write an AVRC program to toggle all the bits of port B continuously with 100 millisecond delay. Okay, so this here you see that you are going to create a 100 millisecond delay. Assume that the system is Atmega 32 with X 8 megahertz. So in the delay we need to okay, the most important thing in delay here is we need to know the CPU speed. Okay, your X speed. Alright, so this X speed will determine your delay. How you going to calculate your delay? How you going to do use the function in order to calculate the delay here. Alright, so in this solution here, okay, so we just focus on this delay only. Alright, because this one here you already know how to do that. Okay, so in this slide, in this part here, in this main program, okay, you see this is your main program and this is your delay function or delay subroutine. Inside of your main program, you know that you need to initialize. Okay, this one here you need initialize your IO port. Alright, okay, and then after that you send the bit to port B and toggle it continuously with 100 millisecond delay. Alright, so now I want to focus here on the delay part. Okay, so in this case here, okay, if you see here, okay, void delay 100 milliseconds, so this is the delay name, okay, or delay function, delay subroutine that you're going to call here. Okay, so void delay 100 millisecond void. Okay, so this is the delay name here. Unsigned integer I for I equal to 0, I less than 4 to 150, I plus plus. So okay, so this one here you going to do to create a 100 millisecond by using a for loop. Okay, this is the first first what we call here first method lah in order to create a delay by using a for loop. Okay, so now we go to this main program here. Okay, so macam biasalah in main program you need to start it with int main word, open curly bracket, close curly bracket, and then you initialize your IO. Depends on whether your IO your port you're going to initialize it as an input or output port. But in this case here, since you want to toggle the bit of your port B, so your port B here become output port. So that's why DDRB equal to OXFF. Okay, so if we only use one port here, which is port B. Okay, and then while one, why we need to use the while one? Because we are going to do a continuously. So that's why we use the while one. Open curly bracket, close curly bracket under the while one punya loops. Alright, and then port B equal to OXAA means that you're going to send out the first value here to your port B, which is AA. Okay, this is your AA actually 1010101010. This is the first number lah you're going to send out to your port B, and then after that, okay, After you send this number here, then with a delay of 100 milliseconds. So that's why here you see here, okay, you call your delay subroutine. Okay, delay 100 millisecond means that it will generate the 100 millisecond delay according to this for loop here. And then port B equal to OX55 means that you now going to toggle this number here. Instead of 101000, now you're going to send 0101 0101. So this is the toggle, okay, which is you, okay, you change from 1 to 0 and 0 to 1, and then call another 100 milliseconds and close curly bracket, and these things here will do it continuously, right? So this is how you're going to create a delay by using a for loop. Okay, next we're going to create a delay by using what we call here a function, okay, a C function, the delay function in your C, okay, in your library. Okay, first you need to define this CPU speed. Okay, so this one here is your CPU speed, or sometimes we call it as your external speed. Okay, so in this case here, if you see define f underscore CPU 1 million means that your CPU speed equal to 1 megahertz. So in the previous example here, since your external here is 8 megahertz, so your CPU should be f underscore CPU should be 800000. Alright, so this one here depends on your CPU speed, depend on the question. What are your CPU speed or external speed? So the value here will be varies. Alright, and then include AVR IO.h. Okay, this one here macam biasalah. Okay, you include your IO header file, and then after that, what you're going to do is you need to include this library here. Okay, util and /delay.h. Okay, so this one here, you're going to create a delay by using a C function. Okay, so this is method number 2. Okay, so that's why we call this library here, util /delay.h. So this is a delay punya library. Okay, macam biasa, int main void, okay, and then you initialize, okay, open curly bracket, close curly bracket down there, and then you initialize your port. Alright, so your port here, so this one here ddrb sama dengan oxff. Okay, so this one here port B, you make it as an output. Okay, this is initialize port. Right, so why you want to do it continuously? So port sama dengan OX3F, so this is the first number that you're going to send. Okay, if you see here, this is 3F065B, so this actually you want to send out your, okay, this is actually you want to send out the value to your 7 segment display. Okay, in this case here, you're going to send, you want to do a counting from 0 to 9. Okay, so this is the value lah that you want to set out. Okay, 3F. Okay, let's see here. 3F. What is 3F? 0111 1111. Okay, and then recall back your 7 segment. Okay, so this is your 7 segment. This is your A, B, C, D, E, F, G, and H. Okay, delete. Okay, 3F, right? 3F, A, B, C. Okay, so this is A, B, C, D, E, F, G, and H. Okay, A, B, C, D, E, F, G. Only H like off, so you want the first number here to send out is number 8. Okay, and then follow with number 1 and etc. Okay, so this is not 3. Okay, sorry, so this is 3 0011, This is 3F. Okay, what happened here is you want to send out the first number here is okay, G padam, G turn off, H of so turn off. So the first number here you can send out is 0. The second number here 06. What is 06? 06, this one is 000, 01, 10. So the second one here is 1 and etc. Alright. So now in between the counting here, okay, you see here you're going to create a delay of 2 milliseconds. Okay, so that's why we put here 2000, okay, to generate a delay of 2 milliseconds. Right, so this number will vary according to what delay that you are going to generate. All right. Okay, and the last but not least is to generate a delay by using a timer. Okay, so this is the step number 3. So step number 3 you will learn in the next module. Alright, so let's look at the Atmega 32 input output problems. Okay, below are a few problems that related to the Atmega 32 IO. Okay, the first one here is input output are scarce. Okay, means that you not enough input output due to demand, for example lah. Okay, so port A only can cater of port A, port B, port C. Each of the port only can cater up to 8 sensor at one time. Let's say like if you're going to connect 16 sensor to your port A. So how to do that? So not enough input output. So are you going to buy a new IC? No. So in order to do that, we need to modify our CPU Microprocessor, okay, in order to combat this IO scarce. Okay, so not enough time to buy Microprocessor with more IOs. Okay, again, since your IO is not enough, what happens is are you going to buy a new Microprocessor? Yes, you're going to buy a new Microprocessor, but sometimes you don't have any, because sometimes you don't have enough time to buy a new Microprocessor because you buy it online and it takes time to ship from the supplier to you, maybe around 7 days or something like that. Okay, you need to use that Microprocessor to start for your assignment, which is the due date is tomorrow. So what are you going to do? Okay, so we need to modify that Microprocessor so that we can accommodate the number of IO that we're going to use. Required modem not readily available, compatibility issues, especially with the assembly language. Okay, some of the Microprocessor cannot usually for the assembly language cannot use it from one computer to another computer, one compiler to another compiler. So that is another problem lah. Or simply no budget. You don't have any budget, to buy the new Microprocessor. So solution, how to overcome this problem here? We use the MSI device. Okay, so MSI device we already learned in the digital electronics, which is what is MSI? MSI stands for medium scale integrated device, which is what are the example of MSI? The example of MSI is some sort of multiplexer, decoder, and encoder, and then you have latch, flip-flop, and etc. That is a MSI. Okay, let's look at the introduction of MSI devices. Alright, so MSI is a medium scale integrated circuit, which has a logic circuit that contains 12 to 99 logic gate in one circuit. Okay, so example of MSI such as multiplexer, decoder, adder, latch, flip-flop, and etc. Okay, so the MSI can be divided into three categories. The first one can call it as a input. Okay, so contoh MSI that belong to input group is such as a buffer, piezo. Okay, what is piezo? Parallel in serial out priority encoder. And the second category here is output groups. Okay, what are the MSI that belong to output groups such as a latch? Okay, so latch you have a lever trigger and edge trigger latch, and you have the SIPO. What is SIPO? Serial in parallel out. And the third group here, both IO, means that it can be input and output at the same time. So example on MSI that belong to this group here are bidirectional buffer, keypad, and coder. Okay, let's look at the first MSI devices. Here is we are going to focus on this buffer and latch, right? So buffer, what is buffer? Buffer is used to temporarily store data while it's being moved from one place to another. Okay, you want going to okay, you're going to send a data from point A to point B, so you need to store that data temporarily. So we use a buffer. So it's an isolated shared data bus, especially for input into micro C. So only one control pin, the rest for data, which is total 9 pin. Okay, and used to increase the number of input pins. Okay, so buffer here used to increase your input. Okay, so this is your buffer. This is the circuit inside the buffer. Okay, if you see here, all right, so this is VCC. Pin 10 is ground. Okay, so this one you need to connect it to ground, and this one here you need to connect to VCC lah, 5 volt. And you see here, pin number 1 or pin 0 here, this is actually your control pin, and pin number 90 always put to ground. So this is your input. Okay, go to your buffer. One. Here this is the output coming out from that buffer. Okay, let's look at this example here. Okay, how we going to increase the number of input. Okay, in the port B from 8 to 60. Right? So let's say now you're going to increase the number of port B, the input from 8 to 60. Right, so this is your port B. Okay, this is the current of port B, which is your port B here connected to switches, 8 switches. Okay, now this 8, now you're going to increase so that it becomes 60. So how to do that? Okay, is it you're going to put another switch here? Okay, and then simply connect to this one. Is it like that? Just connect to here, and another switch here, connect to here, and until 8 bit of switch. Is it something like that? No, you cannot do this because you see here. Alright, so this one here, okay, this is input to your PB0. If you connect your switch, another 8 switch to the same PB0, you see here it will share the same input, which is wrong lah, because one input only for one pin PB0. Okay, cannot share from the same pin here. Alright, because it will clashes. Okay, let's say if you press this one here, this one not press, so what value that will go to here? Okay, is it 1 or 0? So you cannot do that by directly connect this another 8 switch to this port B. So how to do that? Okay, in order to do that here, we need to use the buffer. Okay, so this is your buffer. you need to have a two buffer here. So this is buffer 0 and this is buffer 1. Okay, so this buffer here will connect it. Okay, so I just draw 8-bit. Okay, so this is the input from buffer 0 and this is the output from buffer. The output from buffer 0 will connect it to your switch lah. Okay, so this is VCC, so this is your switch, and then this is buffer 1. Buffer 1 input go to your port B, okay, which is also a 8-bit data, and while this one, the output from buffer will go to your switches. Okay, so this is another 8-bit. So now you have a total of 16 switches. Okay, so remember back, okay, your buffer here, you have a, yeah, this is a control here, okay, at pin 1. Okay, so this one here, this is going to go to PC 0, while this one here will go to your PC 1. Okay, so this is a 8-bit. It is 8-bit. So this is your input here. Alright, so this is the input of your buffer, connect to your switches, and the output here will go to your micro P. Okay, which is to see here, this will go to your port B, pin 7 to pin 0, and this also go to port B, pin 7 to pin 0, which is they're going to share the same port here. So now you're going to write down the program, okay, how to read from this switch and another this switch here. From switch, okay, so this one at the top here I say as a switch 0 to switch 7, while this one is switch berapa yang ni, 8 to switch 15. Okay, how to read the data from switch 0 to switch 7 and switch 8 to switch 15. Okay, in order to do that here, you need to do a programming lah. Okay, first. Okay, so this one here, okay, yang ni akan pergi ke PC 0, and this one here go to PC 1. So this is your control input. Which buffer that you going to use? Is it buffer 0 or buffer 1? According to this one. Okay, so how are we going to write the program here? Okay, first lah. Okay, so here port B are connected to our switch. Is it correct? Okay, so first you include avr/io.h, okay, and then int main void. Okay, after that open curly bracket, close curly bracket. Okay, this first line, what you going to do at this first line, the very first line here. Okay, you need to initialize your port B. Port B now become input or output port. Okay, since it's connected to your switch, so you need to initialize your port B, so your port B become input port. So DDR B sama dengan 0. Okay, so after you initialize your port B as an input port, so you need to enable your pull up resistor. How to enable pull up resistor? By using a port B sama dengan OX. Okay, what about this one here? PC1 and PC0. Okay, so since PC1 and PC0 is what we call a control pin, okay, to select either buffer 0 or buffer 1, so we make port C here as a output port. So DDRC sama dengan OX F, because we want to send either 0 or 1. Okay, if you see here, if you see your buffer here, okay, since this one here connect to 0, okay, in order to enable this buffer here, you need to give 0, because 0, you see bubble here 0 0, you get bubble 1 1 1, and with 1 you get 1. So you enable your buffer. So this buffer here can send this value from input to output. If you put 1, what happened here? This is 1, okay, got bubble, it becomes 0, and this is 0, got bubble 1, and with 0 you got 0. So no value will transfer from your input of your buffer to output of your buffer. Means that the buffer here is disabled. Alright, so next, what you're going to do? Okay, first, now we are going to read the switch from switch 0 to switch 7. Okay, to do that, alright, so the first line here, you need to enable this one. So how to enable B0? Okay, to enable B0, you need to send out port B, sorry, not port B, port C. Okay, because our control here are connected to your port C. Right, port C, the first value they're going to send is 0B11111110. See, this is your PC0. Okay, you need to enable your PC0 while your PC1 is disabled. Okay, so enable, and it is disabled. Okay, then after you enable, so now you can read this value from these switches, go to your port B. Okay, so now you put lah any variable here. Okay, so contoh lah this one ya. Okay, switch A equal to pin P. Okay, so okay, the first 8 switches here, provisions from switch 0 to 7, any value here will go to your switch A. Okay, we go to your variable called switch A. Okay, then after that, what we are going to do? Okay, next we are going to read this another switches from switch 8 to 15. How to do that? Okay, sama juga. Port C 0B 1111 1101. So now you see here. Okay, PC1 you enable, PC0 you disable. Okay, now because we are going to focus on this switch here, so that's why PC0 we enable as PC1 we enable. Okay, so that we can read the switches from buffer 1, while PC0 we disable. So now the microprocessor will not read the switch that coming from buffer 0. Okay, and then you put switch B lah. Okay, so this switch B sama dengan pin P. Okay, next, after that, what I'm going to use dulu. Okay, we can do it continuous. Okay, this is how you going to write down in your assembly language. Okay, macam kita buat tadi, as we did earlier. Okay, the first thing first, you initialize, okay, your port B as a input port. After you initialize, okay, now you're going to initialize your DDRC. Okay, so that your DDRC become output. Okay, so here you see here, okay, you enable the first, there's the PCO, while PC1 you disable, and then you read any value coming from not port here. This is a pin B because this is input. Okay, any value that coming from pin B you put to your R16. Okay, in our case here, we use the switches A to replace the R16. Okay, and then we disable our port C. Okay, we disable PC0. Okay, this one here you enable your PC0 by sending 1. Okay, your PC0, and then after that you're going to read the second the switch coming from the second buffer. Okay, how to do that? Okay, this one here. Okay, so initialize PC1 as output, and then you enable PC1. So this PC1 PC1 with 0. So you enable that one, and then you read the value. Okay, so this one also pin B, not port B. Pin B go to your R17. In our case here, R17 we replace with switch B. Okay, and then you disable your PC1 by sending 1. And then we have a PISO. Okay, PISO is parallel in serial out. Okay, so this is the number lah, the model number. Okay, it used to save number of input pin into micro C or micro P. Has 2 control pin, 1 data input, and which is consist of total of 3 pin that go into your micro P. Okay, so you have a control pin here. Okay, the first one is going to you to either you want to shift or load your data, and the second pin here, this is your clock input. Okay, so this one here you can what we call refer back to your digital electronics punya notes. Okay, how the PISO works. I'm not going to focus on this one. All right, and then we have a latch. Okay, so latch going to store data by level trigger. So latch, you have 2 type of latch. One is level trigger, the other one is edge trigger. Okay, so the detail on how the level trigger, edge trigger, you can refer to your digital electronics. Okay, so this latch here used to increase the number of output pins. Okay, earlier buffer used to increase for input, so latch used to increase the number of output pin. Okay, so latch also have a 1 control pin. Okay, which used to enable which latch that you're going to read and which latch that you're going to off. Okay, so this is the circuit inside of your latch. Right, so this is a latch edge trigger. All right, so to store data by edge trigger. Okay, previously to store data by level trigger. Sama juga, it used to increase the number of output pin, has 1 control pins, and then we have a SIPO. Okay, serial in parallel out, also to increase number of your output. Okay, has 2 control pin. I'm not going to focus on this one here. I'm going to focus on the latch. All right, so this is your latch. Okay, how are we going to increase the number of output pin from port B from 8 to 16? All right, so for example similar to that earlier example. Okay, so this one here, we have a micro P. So this is your micro P, port B. So this is your port B. Okay, just put the port B. So this port B here connected to your LEDs. Okay, so this PB0 and this is PB7. Okay, you have 8 LEDs, PB7, LEDs connected to your port B. Okay, so this is 8. Now you're going to increase this number here from 8 to 60. Are you going to connect, okay, this LED here? Okay, this is another 8 LEDs. To directly to your port B, you cannot do that. Okay, so how to do that? Okay, instead, okay, you're going to use a latch. All right, so this is port B. Okay, so this is your first latch. Okay, so 8 bit go to your latch 0, and this latch 0 here are connected to your LEDs. Another 8 bits of your LEDs. Alright, so then you need a second latch here. This latch 1. Okay, connect to your port B. Okay, this is also another 8 bits. And so this 8 bits. So now you have total of 16 LED go to your port B. Okay, so bear in mind that you have a control input for your latch. Okay, so this one here will connect it to your PC kosong, and this one here will connect it to your PC1. Okay, so let's this is your LED 0 to 7, and this one here is LED 8 to 50. Okay, so how to send the value from your micro P to this LED? How to do that? Okay, similar to earlier. Okay, so you need to include this file lah. Include avr/io.h. okay, and then int main void open curly bracket, close curly bracket down here. Okay, first, since port B here are connected to LED, so you need to initialize your port B so that your port B become output port. What about of PC0 and PC1? Okay, PC0 and PC1 also, okay, you initialize it as a output port. Okay, then Y1 lah. Okay, we want to send out continuously. Okay, so open curly bracket. Okay, so the first one here. Okay, the first number that you're going to send here is to your LED 0 to LED 7. Okay, how to do that? Let's say lah. Okay, this one here I want to make okay, this is your LED. Okay, so this is LED kosong sampai LED kosong 7. This is LED 8 until 15. Let's say lah I want to mix my LEDs so that it will display something like this. Okay, how to do it? Okay, first, okay, I send can. Alright, so port C equal to 0B. Okay, I need to enable, okay, the latch 0 here, the first latch here. Okay, port C 0B 11111110. Okay, so PC0, so this is enabled, while PC1 I disable my latch. Okay, next. Okay, the LED 0 and LED 7 will display this pattern here. So port B equal to what number here? 0B1111 kosong 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 kosong. Okay, why 1111 kosong 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 kosong, not kosong kosong kosong? Why 1111? Okay, because you see here, this is okay common. What type of common LED that I use here? Common scatter. Okay, so common scatter, what happen is if you send 1, your LED will on. If you send 0, the LED will off. Okay, so this go to your port B, and then next, okay, you can call a delay if you have a delay. Okay, so call a delay lah. Okay, delay 1 second punya subroutine. Right, next port C. Now I'm going to send this value to my LED 8 to 15. Okay, so first I need to disable this slash and enable the second slash. So 111 110. See here. Okay, PC1 enable, while PC0 disable. Okay, and then now I send this value lah to my port B. So port B equal to what value here? 0B1010101010 and call a delay 1 second. That's all. Okay, this is how you're going to increase the number from 8 to 16. Okay, let's say now you're going to increase the number from 8 to 24 LEDs. How to do that? So to do that, you need to add another buffer lash lah kat sini. Okay, the third lash. Alright, so this one here, go to your PC2. Okay, control input, and this one here connected to another 8 bit of LEDs. Okay, if you are going to increase to 32, so how many slash do you need going to use here? So 8 latches lah. Okay, it depends on the number of output that you're going to increase. Okay, so this is in assembly language, and we have a bidirectional buffer. So this bidirectional buffer can be either input or output. Okay, it used to control share data bus. Okay, example A74LS245, and you have a keypad encoder. Alright, so I think that's all for today. Thank you.